ओके।
डुएल है।
नहीं और दूसरा नहीं है। Good evening, students. So, in the last session, in the morning session, we have covered up to question number 31. Okay. So, we are discussing the model paper. So, up to question number 31, we have covered. Okay. So, next we will be discussing the part C and part D. Okay. So, part C and part D, it's a scoring section. Okay. These two sections are a very scoring section, and the questions are fixed here. Okay. The questions are fixed. So even if you solve, okay, so suppose see 32 question, it's occurring on equivalence relation. So if you solve 4 to 5 examples based on equivalence relation from the first exercise, this question will be covered. Similarly, see 33rd question, it is occurring from inverse trigonometry. So if you solve from the second exercise in inverse trigonometry, simplest form, four of 6 7 examples are given. So if you solve all the 6 7 example, this example will get covered. Next, 34th question, symmetric and skew symmetric. Already we have discussed how to express the given square matrix as sum of symmetric and skew symmetric matrix. Next, differentiation question we have. Next, 36th is also differentiation. So two questions have occurred from differentiation. Two questions have occurred from differentiation, and one question has occurred from application of differentiation. Okay. So here we have having three questions here. Okay. So we'll try to analyze it with the blueprint given. Okay, and then start with the solution part. Okay. So see here, see we have three questions here from apply differentiation. So differentiation, see, differentiation, three questions, 35, 36 and 37. 35, 36 are from differentiation, 37 is from application of differentiation. Then there are two questions from integration. Okay, one question is from integration by parts. So see, this question has occurred from by parts. Okay, and then 39th question has occurred from differential equation. Okay, we will discuss it. Okay. Next, 40th question. See, question number 40 has occurred from vectors. Okay, and 41 also has occurred from vectors. Okay, so differentiation and vectors are fetching two questions each. Okay, in the part C, and then the 42 question, it has occurred from probability. Okay, it has occurred from probability. Okay, next, in the part D, we can see in the part D. Okay, in the part D. So in the part D, the first question we have from relation and function, and this question we have covered. Next, 44th also we have covered. So see two questions, one question from matrix and one question from determinants is occurring here. Okay, one question is from matrices and another question is from determinants. So again, if you know are good with matrices and determinants, you will cover two questions. This relation and function question is very easy, and you can cover the question on differentiation. Okay, and in the last few classes we have studied this question, and yesterday we discussed this question also. Okay, so here you need to attempt any four. So here out of four, you can see 1 2 3 4 5 6. Okay, and 7, you can prepare this question also because this is the derivation, and one derivation is sure. So this is equation of line through a point and parallel to a given vector, the first derivation in 3D. So 7. Okay, and also we will discuss this solution for 49th question from differential equation. Okay, so even if you skip the differential equation topic, no problem. Okay, only try to solve the examples of order and degree. Okay, order and degree of differential equation, that is exercise 1 in differential equation. So even if you do this and skip a differential equation, there is no problem because only one 5 mark question we are getting here and one question we are getting in 3 mark. Okay, so rest of the topics if you do properly, later at the end I will discuss the strategy also. Okay, which chapters you can focus more. Okay, and then the last part uh, part E. Okay, 6 plus 4 mark. Okay, so this is a 6 mark and 4 mark question. So this 51 question we had to discuss, we will discuss it here today. This question we have discussed already, LPP question. Even the question on matrices, finding A inverse we have discussed, and finding the value of k, this question is also discussed. Okay, so part D and part D maximum questions are discussed. Part C, few questions we will discuss the solution now. Okay, pay attention. Okay, so pay attention here. And if you have any doubts, you can put it in the chat box. Okay, so we will discuss at the end. A few more doubts we will discuss. Okay, and last I will be discussing the strategy, how you can cover up the revision. Okay, and which chapters you can focus on. So at least you can attempt more than 70 marks out of 80. Okay, so what will be the strategy that I will discuss at the end of this session. Okay, so pay attention, try to understand. So we will begin with the discussion on part C. Okay. So the question over here is show that the relation R in the set A 1, 2, 3, 4, 5 given by R is equal to A comma B mod of A minus B is even. Okay. Is an equivalence relation. Okay. So we need to show that it is a equivalence relation. So a relation is a equivalence relation if it is reflexive, symmetric, and what transitive. Okay, if it is reflexive, symmetric, and transitive. Okay, so see in the solution part, first what we are doing is we are considering R is equal to, okay, R is equal to AB. Okay, R is equal to AB mod of A minus B is even. Okay. Defined on, okay, so R is a relation defined on what set A, and what is the set A given? Set A is given as 1, 2, 3, 4 and 5. So first 5 natural numbers are being given. Okay, so here for reflexive, see first case I will be discussing for reflexive. So for reflexive, case what we are doing is we are considering for, okay, so we have solved 9 Uh, I think maximum questions we have solved on this. So, and I think this question also has been covered there when we have discussed. Yeah, okay, so you can go through that revision sessions. So in that revision sessions already this question is covered. Just I am explaining you the steps. Okay, so here for reflexivity we need to consider one element A belonging to what set A. Okay, and apply the condition. What is the condition? A minus. So see for reflexivity we are considering A minus A. Okay, so A minus A we know it is equal to 0, and we know any number ending with 0 is what even. Okay, so therefore what we can do, we can write A comma A belongs to R. Okay, so for all A belongs to A comma A belongs to R. Therefore it is a reflexive. Okay, so the relation, the given relation is a reflexive relation. Okay, next similarly we need to discuss for symmetric. Okay, so in case of symmetry what we are doing, we are considering let A comma B belongs to what R. So if A comma B belongs to R, it implies what mod of A minus B is even. Okay, mod of A minus B is even. Or see, we can take out a negative sign common. So this will be minus times of. Okay, so when I take negative sign common, we get B positive and A will be negative. Okay, B will be positive and what A will be negative. So I can write this same as, so see the negative value of this also will be because of the modulus sign. Okay, and then this will be in the form of what mod of B minus A. And if mod of B minus A is even, meaning of this is what is also even. So if there is change in the sign, it doesn't change whether the number is odd or even. Okay. So change of sign will not change whether it is a even or odd number. So even if we change the sign here, okay, we are getting B minus A, and B minus A mod of B minus A will also be even. And therefore we can write B comma A belongs to R. Okay. Now see, we started by considering a element ordered pair belonging to R, and exactly the mirror image B comma A is also belonging to R. So it is a symmetric relation. So it is transitive, it is reflexive and symmetric. Next we need to discuss the transitivity. I'll solve it here. So in case of transitivity, we need to consider two ordered pairs, A comma B and what? B comma C belongs to what? R. Now see, if A comma B belongs to R and B comma C belongs to R, meaning is these both are even. So see, mod of A minus B and what? Mod of B minus C is also what? Even. Okay. Or see, A minus B, I can write it as A minus B. Okay. Plus I will write B minus C. Okay. Now see, plus B and minus B will cancel. Okay. And we get A minus C. Or A minus C, I can consider it as mod of A minus C. So I can write it as a mod of A minus C is also what? Even. Okay. So we have obtained A comma C belongs to what? R. Okay. So A comma B and B comma C belongs to R. We have shown that A comma C also belongs to R. Okay. And since A comma C belongs to R, okay, we say that it is transitive. Okay, the given relation is also transitive. The same example we have discussed. You can refer that video also on relation and function. Okay, so the same question is been explained there. And one more such question is there. Mod of A minus B is a multiple of 4. Okay, one more question. And there also we are applying the same logic. Okay, we are applying the same logic. Okay, so this is the question number 32. So since the given relation is reflexive, symmetric, and transitive, we say that it is a equivalence relation. Okay, so 3 mark and 2 mark section is very important. If you score well in 3 mark and 2 mark, you can easily score above 70 in the maths paper. 70, 75 you can easily score. So 3 mark and 2 mark section are very important. Okay, so try to prepare the chapter completely. Next, question number 33. Okay, question number 33. So in question number 33, we need to find out the simplest form. So write the what simplest form of tan inverse root of 1 plus x square minus 1 upon x. Okay, so this example we are solving by substitution method. Okay, ಇಲ್ಲಿ ಏನು ಮಾಡಬೇಕು ನಾವು substitution method ಮಾಡಿ simplify ಮಾಡಬೇಕು. So here we will be substituting x is equal to tan theta. Okay, or theta will be equal to what? Tan inverse x. Okay, so now say using the substitution, we obtain it in the form of say tan inverse. Okay, tan inverse root of 1 plus tan square theta minus 1 divided by what it will be tan theta. So where there is x, we have replaced it by tan square. So on simplifying it further, we get see tan inverse. See 1 plus tan square is sec square theta, and root of sec square theta is sec theta. Okay, so sec theta. Okay, we get it in the form of what? Sec theta minus 1. Okay, we get it in the form of what? Sec theta minus 1. See sec theta minus 1 divided by tan theta. Okay, so on further again simplifying, we get see tan inverse as it is. So sec theta can be written as 1 upon cos theta minus 1 and divided by tan theta, I can write it as sin theta upon what? Cos theta. So on again further simplifying, we get tan inverse. LCM will be cos theta. So 1 minus cos theta upon cos theta and divided by sin theta upon cos theta. So denominator cos theta will cancel. Okay, and then we will get it in the form of, I'll simplify it here further, tan inverse. Okay, tan inverse 1 minus cos theta upon what? uh, sin theta. Okay, so again we need to simplify it further. Okay, so to simplify it further, what we are doing, we are making use of the formula for 1 minus cos theta. Okay, 1 minus cos theta. We know 1 minus cos theta is 2 sin square theta by 2. So this will be equal to tan inverse 2 sin square theta by 2 divided by 2 sin theta by 2 cos theta by 2. Okay, So say square and sine theta by 2 will cancel. 2 and 2 will cancel, and sine theta upon cos theta is tan inverse of tan theta by 2. Okay, or tan inverse of tan theta by 2, it will be equal to theta by 2, or theta value we know it is equal to tan inverse x. So theta by 2 will be equal to, see, the final answer will be tan inverse x upon 2. So tan inverse x upon 2 is the simplified form. Okay. So for this example, first we are applying the substitution. Okay. We are making use of the substitution. X is equal to tan theta. And then on simplifying, we get it in the form of 1 minus cos theta upon sine theta. 1 minus cos theta upon what? Sine theta. Okay. And after using 1 minus cos theta upon sine theta, after this step, here we have it in the form of tan inverse tan theta by 2, which is equal to theta by 2. And last step, you need to replace theta by 2 with its value, that is tan inverse x. Okay, so tan inverse x upon 2 will be the final. Okay. Next, we will discuss question number 34. So question number 34, just I will be discussing the steps. Okay, rest you all know it already. Okay. And while our discussion, we have solved these examples. I think the same example we have solved. So the question is, express A is equal to 3, 5, 1 minus 1 as the sum of what symmetric and skew symmetric matrix. Okay, so we need to express it as a sum of what symmetric and skew symmetric matrix. Symmetric and skew symmetric matrix. Okay, so see here, what we are doing is we are writing this A, okay, in the form of what P plus Q. Okay, P plus Q, or this P we are considering it as 1 by 2 A plus A dash. Okay, and Q we are considering it as 1 by 2 A minus A dash. Okay, so here in the first step, what we can write this formula, and that is A is equal to P plus Q, or 1 by 2 A plus A dash and 1 by 2 A minus A dash. Okay, and then in the step number 2, what we need to do, we need to consider P as 1 by 2 A plus A dash. Okay, obtain this P value, and then show that P dash is equal to P. So when we show this P dash is equal to P, we get 1 upon A plus A dash is a symmetric part. Okay, it's like showing, when we prove P dash is equal to P, we show that it is symmetric. Similarly, in the next step, what you have to do, you have to show Q. Okay, Q is equal to 1 by 2 A minus A dash, obtain Q value, and then we need to show Q dash is equal to minus Q. Okay, and when Q dash is equal to minus Q, Q will be a skew symmetric. Okay, it will be a skew symmetric matrix. Okay, it will be a skew symmetric matrix. Okay, and then finally we need to consider this P value as 1, and in the equation 1 you substitute and show that the sum of P plus Q is equal to A. Okay, that is the last step. So you need to show A is equal to P plus Q. Okay, so first we, by using this formula, obtain P, show P is symmetric, then obtain Q and show Q dash is equal to minus Q, which verifies that Q is skew symmetric. And then the last step, third step, you need to show A is equal to P plus Q. Okay, so this one you all try it, it's very easy. Okay, A and A dash, A and its transpose. Okay, if there is any doubt in this, you can put it in the chat box, or we will discuss the next one. Okay, next example. Okay, next, differentiate sine square x with respect to what? E raised to cos x. Okay, we need to differentiate sine square x with respect to what? Cos x. Okay, so here we can consider one function as, okay, u, and another function as what? V. So it is differentiating one function with respect to other function. So what we can do here is, first we will differentiate u function. Okay, so see, u is equal to, I'll consider it as sine square x. Okay, and then when we differentiate we get du by dx. Okay, so du by dx, it is in the form of f of x raised to n. Okay, f of x raised to n or x raised to n formula you have to apply. So x raised to n, x square derivative will be what, 2x square. Similarly sine square x derivative will be 2 sine x into cos x. Okay, so it will be du by dx will be 2 sin x cos x. Similarly we have to consider as e raised to cos x, e raised to cos x, and dv by dx will be, okay, dv by dx will be e raised to cos x. Okay, and derivative of cos x is minus sin x. Okay, so this is 1 and this is what, 2. So you have to divide both, we will be getting the value. Okay, so dy by dx. Okay, or you can write different derivative of one function with respect to what other, will be equal to. Okay, so this will be equal to, so divide 1 with 2. So see, du by dv will be equal to du by dx divided by dv by what, dx. Okay, so see, du by dx we have obtained 2 sin x cos x divided by e raised to cos x minus cos x. Simplify, so the answer will be minus 2 sin x divided by e raised to cos x. Okay, so this will be the final answer. Okay, so this is how we have to differentiate one function with respect to other. Next, a very simple question is given. The next question, okay, a very simple question. X raised to sin x differentiating with respect to what, x. Okay, so this is given from logarithmic differentiation, logarithmic functions. So y is equal to what it is, x raised to sin x. So first step we need to apply log on both sides. So we get log y. Okay, log y is equal to log of x raised to sin x. And then by applying the okay, logarithmic laws, we get log y is equal to sin x into what, log x. Okay, so here we need to apply the product rule. Now we will be differentiating this. So differentiating with respect to what, x, we get, see, 1 by y dy by dx will be equal to, see, sine function as it is, derivative of log x is 1 upon x plus log x as it is, derivative of sine x is cos x. Or the final step, dy by dx will be equal to y into sine x upon x plus log x into cos x. And then final step we need to substitute y value. Y value is, so the final answer will be dy by dx will be equal to x raised to sin x in bracket sin x upon x, and the same term will occur here. Okay, so this will be the answer. So two questions have occurred from differentiation. One is one function with respect to another, and another one is just on logarithmic differentiation. Okay, so most of the time the question here will be asked on parametric differentiation and logarithmic differentiation. So three types, parametric, logarithmic, and exponential. Okay. Okay. Next question is on find the interval in which a function f of x is equal to 10 minus 6x minus 2x square is what, strictly increasing. Okay. So increasing, decreasing function. Okay. Strictly increasing and strictly decreasing. So for increasing and decreasing function, we know if f dash of x is greater than what, 0. Okay. If it is greater than 0, then that function is strictly increasing. And if f dash of x is less than 0, then the function is what, decreasing. The function is decreasing. Okay, so we'll try to solve this. So but they are asking us the intervals. Okay, so we need to find out the intervals where it is strictly increasing, they are saying. Okay, strictly increasing. Okay, So the question is as it is picked up from the book, okay, from the exercise, I think 6.3, okay, not 6.3, application of derivatives, as it is the question is picked up, okay. So see, part C maximum questions they are picking it from the textbook, okay. Only ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಪಾರ್ಟ್ ಎ ಸಲುವಾಗಿ ನಿಮ್ಗೆ ಸ್ವಲ್ಪ ಎಕ್ಸ್ಟ್ರಾ ಪ್ರಿಪರೇಷನ್ ಮಾಡಬೇಕು, okay. ಪಾರ್ಟ್ ಡಿ, ಪಾರ್ಟ್ ಇ, and part C, part B, all these questions will be from the textbook itself, okay. So miscellaneous part, exercise examples, and solved examples, okay. So these three sections if you have covered of a particular chapter, okay, then you can easily solve the part C, B, and D of the question paper very easily, okay. But you need to cover the solved examples before the exercise examples, and the miscellaneous examples, okay. So see, now pay attention further. So the given function, see the function f of x, the value of the function f of x is, see, f of x is equal to 10 minus 6 x minus what, 2x square. So first we will take the derivative of this function. So f dash of x will be equal to 10 derivative is 0. So it will be minus 6 minus 2x square derivative will be minus 4x. Okay. Now what we are doing is to find out the point. Okay. What we are doing is we are equating f dash of x to what? 0. So when we equate f dash of x to 0, we get minus 6 minus 4x is equal to 0, or on simplifying we get x is equal to minus 3 by 2. Okay. So based on this point we can get the two intervals here. So okay, x is equal to minus 3 by 2, it splits r into, it is a set of real numbers into two intervals, okay. So we will get two intervals. The first interval will be minus infinity to minus 3 by 2, okay, and then see minus 3 by 2 to infinity, okay, minus 3 by 2 to infinity. So we will be getting two intervals, okay. We will be getting these two intervals. Mhm. And since they are asking strictly increasing, okay, strictly increasing, we don't get the closed interval here, okay, we get both the open intervals. So if strictly it is not there, then we can make use of the, okay. So here, so these are the two intervals, okay. So the first interval is minus infinity to minus 3 by 2 and minus 3 by 2 to infinity. Now we need to check in which of these intervals the function is strictly increasing, okay. So see, for your understanding, I'll consider the number line minus 3 by 2, okay, and then minus infinity and 0, and then we have what, plus infinity, okay. Now see, I'll consider the function, see, f dash of x is equal to, f dash of x is equal to minus 6 minus 4x, okay. So try to substitute any one point from this interval, okay. So we will check minus infinity to minus 3 by 2, minus 3 by 2 is minus 1.5. So you can substitute the immediately next point, minus 2. So if I substitute minus 2 here in this interval, minus 4 into minus 2, it will be plus 8, plus 8 minus 6, okay, plus 8 minus 6, it will be, okay, plus 2, and plus 2 is what, greater than 0. Yes, sir. So say, okay, for x belongs to, okay, for x belongs to, you can write for x belongs to minus infinity to what, minus 3 by 2, f dash of x is what, greater than 0. F dash of x is greater than 0, okay. Now if the derivative is greater than 0, then the function is what, strictly increasing, okay. So therefore the answer will be f dash of x is what, strictly increasing in the interval what, minus infinity to minus 3 by 2, okay. Now if you want the strictly decreasing interval, okay, it will be minus 3 by 2 to infinity, you need to check it. So if there it is positive, then it will be strictly increasing, or else it will be strictly decreasing. So see, one we will check, we will consider a point, I will consider the point as 0. So if I substitute 0, we will get it as -6, and -6 is what? Less than 0. So it will be strictly decreasing in the second interval, that is -3/2 to infinity. Okay, so only they have asked where it is strictly increasing. So it is strictly increasing in -infinity to -3/2. Okay, next, hope the solution is clear. So sometimes the question is been asked on increasing, decreasing, and sometimes you may expect a question from maxima, minima here. Okay, maxima and minima. Okay, so both the questions you be ready. Okay, see here, any 6 questions you need to attempt in part C. Okay, so the first question is at least very easy. You can get it. Second also you can get. Third also. Fourth, fifth. If you are good with differentiation till 5. So even if you leave this question 37, okay, then you need to depend on integration part. Okay, so integration here, the question has occurred from by parts. Here it is on differential equation. Next 40th question is again easy. It has occurred from vectors. Okay, so if you want to skip this question, you need to be very perfect with vectors. Okay, vectors. So see 1, 2, 3, 4, 5, 6, 7. Okay, so even if you skip 37th, okay, integration and vectors you need to do it properly. Okay, or better be ready with increasing, decreasing, and maxima, minima. So it will help you. Okay, next. Okay, so after increasing, decreasing, we have say x sine inverse x and dx. Okay, x sine inverse x dx. We need to integrate. Okay, we need to solve it by integration by parts. Okay, so 2 minutes, 1 minute. We will discuss it. Yes. Okay. So see here we need to solve this example by making use of by parts. Okay, by parts. So we will discuss this solution. Okay, I will be discussing it here. Okay, so pay attention. Question number. Here we need to solve it by parts. Okay, so in the previous class we have used this rule. So x sine inverse x and dx. Okay, so by parts the statement is what? U into v and dx. The formula is u into integration of v minus integration of v and dx into what? And du by dx and dx. Okay, so this is the formula. By making use of this formula we can simplify it easily. So in your exercise 3 questions have been given: x sine inverse x, x tan inverse x, x cos inverse x. Okay, so better practice all these three. All these three you all practice. So here we will consider sine inverse x as the first function. Okay, and x as the second function. So inverse trigonometric first and then algebraic. Okay, as per the Euler rule. As per the Euler rule. Okay, we can consider. and simplify it. So see first function as it is, sine inverse x as it is. Okay, sine inverse x as it is. I'll consider this function as I. Huh? So I is equal to I is equal to x sine inverse x. Okay, so the first step, sine inverse x as it is, integration of what, x dx minus integration of x dx into d by dx of sine inverse x dx. Okay, so on simplifying it further, we get sine inverse x as it is, x integration will be x square upon 2. Okay, minus integration of, so integration of again x will be x square upon 2 into derivative of sine inverse x is 1 upon root 1 minus x square dx. Okay, so we will simplify this part. So see x square sine inverse x upon 2 as it is. Okay, now see I will take out 1 by 2 common. Okay, so 1 by 2 I am taking out common, and see plus sign I am taking out common, that minus sign I am shifting it inside. Okay, so it will be x square 1 minus x square and dx. Okay, so we have shifted this negative sign just to make the adjustment for root 1 minus x square. So see further what we can do. Okay, so see further, so x square sine inverse x upon 2 as it is. Okay, plus 1 upon 2 as it is. So this will be, say I will be adding 1 and then subtracting 1. Okay, divided by root 1 minus x square and dx. Okay, so on simplifying this further, see x square sine inverse x by 2, it will be as it is, 1 by 2 as it is. Okay, so in the bracket I will split this, I will split the denominator, so we get a root of 1 minus x square dx. Okay, minus 1 upon root of 1 minus x square dx. Okay, so we need to simplify it further now. Okay, so this will be equal to, see pay attention. Okay, so here the first term will remain as it is, x square sine inverse x as it is upon 2. So in the bracket 1 by 2. Okay, so see the root of 1 minus x square. Yesterday we have discussed root of a square minus x square. We are applying the same formula. So it will be x by 2 root of 1 minus x square. Okay, plus 1 by 2 sine inverse x. Okay, sine inverse x. Similarly, minus, see 1 upon root 1 minus x square, it will be directly sine inverse x plus c. Okay, plus c. So multiply 1 by 2, we will get the final answer. So it will be x square sine inverse x upon 2. Okay, plus 1 by 2 into x by 2, it will be 1 by 4. 1 by 4 root of 1 minus x square x by 4. Okay, and then see 1 by 2 minus 1, it will be minus 1 by 2, and minus 1 by 2 into it will be minus 1 by 4 sine inverse x plus c. So you can keep this as the answer, or you can take 1 by 4 common and simplify. Okay, so this will be the answer for x sine inverse x. Okay. So here first we need to apply by parts, and then we need to apply, see here in the step number. Okay, so practice it once or twice. You need to practice each and every question, and then only you can get this. Okay. So see here we need to integrate it once by using the special type and the second type. So here we are getting it in the form of x by 2 root of 1 minus x square a square by 2 sine inverse x and the integral of the second term will be sine inverse x. Okay, so simplify these two. 1 by 2 minus 1, it will be minus 1 by 2, and minus 1 by 2 into 1 by 2, it will be minus 1 by 4. Okay, so this will be the final answer. Next. Okay, so 38th is over. 39. Okay, so in question number 39, we need to find the equation of the curve passing through minus 2 comma 3. Given that the slope of the tangent to the curve at any point is 2x upon y square. Okay, so this question has occurred from a differential equation. Okay, so this question has occurred from a differential equation. Question number 39. Okay, question number 39. It's from differential equation. We will discuss this. So see, the slope of the tangent is equal to the slope of the tangent is equal to 2x upon y square. So we will discuss it. Pay attention. Okay, so it's given dy by dx is equal to. So see, equation of the we know slope of the tangent is nothing but dy by dx. Okay, so see, it's given solution. So see, dy by dx is equal to dy by dx is equal to 2x upon y square. So it's given in the question. Slope of tangent is equal to a 2x upon y square. So this is already given to us. Split the variables. Okay, so by using variable separation, we can write it as y square dy is equal to 2x dx. Okay, now by integrating on both the sides, we get y square dy is equal to 2 into x dx. Okay, or this will be y cube upon 3 is equal to 2x square plus c. Okay, or on simplifying, I'll consider this as c1. Okay, so say y cube will be equal to 3 1 minute upon 2. So this 2 and 2 will cancel. So it will be y cube upon 3 uh, x square plus what c1. So on simplifying it further, what do we get? Say y cube will be equal to 3x square plus what 3 c1. Okay, or we will write it as 3x square plus what c. Okay, where c is equal to 3 c1 we will consider. Okay, now see this equation 1, it is passing through the point 2 comma minus 3. So equation 1, it passes through the point what minus 2 comma 3. So we need to substitute and find the value of c. Okay, so where there is y, we will be replacing it by 3. So we get 3 cube is equal to 3 into minus 2 square c1. Okay, or 27 is equal to 3 4 so it will be 12 plus c1, or on simplifying we get not c, sorry c, not c1, we have replaced c1 by c. So this will be equal to what 15. Okay, so c value will be equal to 15. So the final equation will be um, equation will be y cube is equal to 3x square plus what 15. Okay, so this equation 2 is the required equation of the curve. Okay, so this example has occurred from differential equation. Okay, differential equation, slope of the tangent is given to us, and by using variable separable method, first we have obtained the equation of the curve, and then to find out the value of c, the constant, we are okay considering the equation is passing through at minus 2 comma 3. So by replacing y and x and simplifying it further, we get c is equal to 15. So this c is equal to 15 we are substituting in the equation 1. So we get y cube is equal to 3x square plus 15, which is the required equation of the curve. Okay. So part C, I think we have covered maximum questions here. So pay attention here now. Yes. Okay. So up to question number 39 we have covered now. Okay. And see question number 40, show that the position vector of the point P which divides the line joining A and B having position vectors A and B internally in the ratio m is to n is m into vector B plus n into vector A divided by m plus n. Okay. So here we need to derive the formula, okay, for point of internal division. Okay. So see, this is AB. Okay, this is AB, and I'll consider P as a point which is dividing them in the ratio at m is to n. Okay, and from the origin we are considering, okay, the three vectors. Okay, position vectors. Position vector of A is vector A. This is vector R we will consider, and this is vector B. Okay, so we have done the derivation. The same derivation we need to repeat it here. Okay, so you all go through the class on vectors for this 40th question. Okay, next 41. Okay, question number 41. I think this example also we have discussed. Now find the unit vector. Okay, find the unit vector. Okay, find the unit vector hmm, to each other, to the vectors a plus b and a minus b, where a is 3 I cap plus 2 j cap plus 2 k cap, and b is I cap plus 2 j cap and minus 2k. Minus 2k. So see here what we can do. So first what we have to do is, I'll give you the hint. Okay, so find out a plus b. Okay, we need to find out what a plus b. So whatever a plus b value we will get, we will consider it as vector c, and a minus b value we will consider it as what, a vector d. So we have got vector c and vector d. Now they are asking us to calculate what, a unit perpendicular vector. Okay, so unit perpendicular vector, if we want to calculate, we are making use of the formula. So suppose n is the unit perpendicular vectors to the vectors c and d. Okay, so we need to make use of the cross product. Okay, so c cross d, okay, divided by a mod of, okay, divided by mod of vector c and vector d. Okay, so this will be the unit perpendicular vector formula. Okay, so you know how to calculate c cross d. C cross d, the determinant method you have to use, you will get c cross d and then calculate its modulus. So this will be the formula for a unit perpendicular vector. Okay, so once again we will discuss. First we have to find out a plus c, next you have to find a minus b. Okay, so a plus b you all consider it as vector c, a minus b you all consider it as vector d. Okay, and then after that, by using the formula, n cap is equal to c cross d divided by mod of what, c cross d, we will get the required perpendicular vector. Next, question number 42. Okay, question number 42. So question number 42 also we have solved it on the class, in the class of probability. So see, a bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the bag is selected at random, and a ball is drawn at random from the bag. It is found to be red. Okay, find the probability that the ball is from the what, first bag. Okay, find the probability that the ball is from the what, first bag. Okay, from the first bag. Okay, so the same question we have discussed it in probability part. Okay, so here we need to make use of Bayes theorem. Okay, Bayes theorem and simplify. Okay, Bayes theorem we need to make use and simplify, and this question also has occurred from the exercise 3. Okay, in probability. So in Bayes theorem we have discussed 3 questions, and I think we have covered this question also. So the same type, same procedure you need to follow. Okay, so you need to make use of the formula for what, Bayes theorem. P E1 upon what, A is equal to P E1 into p a by e1 and divided by, okay, divided by p e1 into p a by e1 into plus p e2 p a by e2. Okay, so this is the formula of Bayes theorem. Okay, so e1 and e2 two events by a. Okay, so a it's already the event of what, in this case it will be a will be the event of getting a red color ball. Okay, getting a red color ball. Okay, so try it. So 42 you all do it for homework. Next, and already we have discussed this question. Next, we will start with the part D. Okay, part D of the question paper. So in the part D, the first question is from relation and function. Okay, so see, every question is from a different chapter. So if you go through the blueprint properly, so on whichever chapter the 5 mark question is present there, only there you can focus. Okay, so see here 43rd question. Okay, 43rd question. Okay, then 44, 45, 46. So all questions are a different level. Okay, so all are from the different chapters. So see 43rd question also we have discussed it. But to once again, I'll discuss you the method, because when we were discussing in the revision class, that time the syllabus got reduced. Okay, and there we have solved it by using composition method, but we can solve this by using one and on two. I think both the methods we have discussed. So, but better you all try to use the first method. Okay, that is showing the function is one and on two. Okay, if you show the function is one and on two, then the function will be invertible. It will be a invertible function. Okay, in this case, and then find the inverse of the function. Okay, find the inverse of the function. Okay, so if you show it is one and on two, then it will be invertible, and then we can also find the inverse of the function. So 43rd question, I'll be discussing it here. So pay attention. Try to understand the method, because we can solve this by two methods. Okay, either by one and on two, and by composition of function. But composition of function concept is deleted this year. Okay, so they have deleted. So better try to solve it by using one and on two concept. Okay, so we will discuss the proof for this question, solution of this question. So here, see, you need to understand what is the domain and range. See, domain is a natural number, and y is the codomain. Be a set of function, be a function defined as f of x is equal to 4x plus 3. Okay, so the given function is a linear function, see 4x plus 3, where y is equal to y belongs to n, y is equal to 4x plus 3 for some x belongs to n. Show that f is invertible. Find the inverse of what? F. Also, we have to calculate the inverse of F. Okay, so see, pay attention. Solution. So first we have to consider the given function. So the function f of x is equal to 4x plus 3. Okay, the function is 4x plus 3. Okay, the function is 4x plus 3, and it is defined on, okay, and it is defined on C. So the function is defined on n to y. Okay, it is defined on n to y. Okay, so here what we are doing is, first we will show this the function is what. So you are right, as it is given in the function. So f is a function from what? C. F is a function from n to y. Okay, defined as f of x is equal to 4x plus 3. So this is the first statement you will be writing, and then we will be uh, proving it for 1 1. Okay, for 1 1 case. So for 1 1, what we will be doing is we are considering let f of x1 is equal to what? F of x2. Okay, So this will be 4x1 plus 3 is equal to what? 4x2 plus 3. Okay. So 3 and 3 will cancel off. So it will be 4x1 is equal to 4x2. 4 and 4 will cancel off, and we get x1 is equal to what? X2. Okay. We get x1 is equal to x2. And since x1 is equal to x2, we say f is a 1 1 function. Okay. F is a 1 1 function. Now in case of onto, okay, in case of onto case, we need to show that for every y there is a image pre-image x in the domain. Okay, so what we will do is let okay y belongs to, okay, y belongs to, say, y must belongs to what? The codomain. Okay, it must belong to a codomain. So here I'll write it as codomain. Codomain be any element, be any element, be any element such that it's a pre-image. Pre-image is what? X. Okay, its pre-image is x. That is f of x is equal to what? Y. Okay. So now see, try to convert this given function in terms of what? Try to convert it in terms of x. So we get, see, 4x plus 3 is equal to y, or 4x is equal to y minus 3, or x will be equal to what? Y minus 3 upon what? 4. Okay, y minus 3 upon 4. And this will belong to what? R. That is the, sorry, n here in this case. And that is the domain. Okay, it is the domain. Okay, so we can see every element. Okay, that is every element of codomain is having a pre-image in domain. Okay, so that is f is what? Onto. Okay, so f is onto. So see, we can express y in terms of x. So it is a onto function. Okay, so therefore what? F is bijective, and since it is bijective, it is invertible also, or invertible. And since it is invertible, whatever this value we have got, x equal to y minus 3 upon 4, this will be the inverse function. Okay, so we need to write it as, see, f inverse, okay, of x is equal to, f inverse of x is equal to, replace y with x, so it will be x minus 3 upon 4. Okay, so this will be the inverse function. So the inverse function is x minus 3 upon 4. Okay, x minus 3 upon 4 will be the inverse function. Okay, so first step what we have to do, see, we need to show that it is 1 1. Okay, so we need to show if f of x1 is equal to f of x2 implies x1 is equal to x2. This is the first step for 1 1 function. Next, for onto, we need to show for every y that is codomain, there is element such that its pre-image is what? X. So we need to express y in terms of x and show it is onto. And once we have shown it is onto, it will be bijective or it will be invertible. Then to find out the inverse, okay, whatever this equation 2 we have got. Okay, this I'll consider equation 2, this I'll consider it as equation 1. So this equation 2, you need to replace y with x. Okay, so f inverse x will be x minus 3 upon 4, and this will be the inverse of the given function. Okay, so better follow this method if the question is asked. So 1 1 and on to method you all follow. Next question on matrices we have. Yes, matrices. So see, if a equal to 0 6 7 minus 6 0 8 7 minus 8 0, b is equal to 0 1 1 1 0 2 1 2 0, and c equal to 2 minus 2 3. Okay, and then we have to calculate first ac, we have to calculate. Next we have to calculate bc, and then we have to verify that, see, a plus b into c is equal to ac into bc. Okay, so simple, what you will do is first solve the LHS and then solve the RHS. So, and when you are solving the LHS and RHS, all the terms are being calculated. So first solve the LHS, consider it as equation 1, and then solve the RHS. So first we have to solve the bracket here, A plus B, and whatever the answer you get, multiply it by C. So you will get the required LHS. Okay, so first you solve the LHS and consider it as equation 1. Next solve AC and BC, add them, you will get the RHS, consider it as equation 2. Okay, now be careful with the order of the matrix. See, in this case it is 3 cross 3, 3 cross 3, and then here it is 3 cross 1. Okay, so be careful. We are making use of which rule here? CR rule. Okay, column into row. Okay, and then solve it. You will get the required answer. Okay, so 44th also you all tried. I think we have solved this during the class. I refer that and do it. Next, question number 45. Okay, so see in question number 45, solve the system of linear equation by matrix method. Okay, so we know in matrix method, again we will discuss the steps here. So we need to split the system of equation into three matrices: matrix A, and then a matrix B, and matrix X. Okay, so X, it will consist of X, Y, and what? Z, unknown variables. And then we need to use, okay, the matrix method. So by matrix method we get A into X is equal to B, or X will be equal to what? A inverse B. Okay, so this is the equation. So we have to find A inverse. A inverse, how we calculate? A inverse is equal to 1 upon determinant of A into what? Adjoint of A. So using this method, first calculate A inverse and then substitute it in the equation 1 and calculate the value of what? X, Y, Z. Okay, so this is a fixed question and every year it will be occurring. Okay, so practice it properly, solving the system of equation by a matrix method. Okay, so matrix method, the question is fixed, and even the question on multiplication of matrix is also fixed. So every year these questions are fixed. 44, 45, even reflexive, this show that it is invertible. Even this question is fixed, or instead of this, we have solved a few questions to check whether the function is what? 1 1 or on 2. Okay, so go through that video over there. Okay, next question number 46. Okay, question number 46. See, if y is equal to 3 cos log x plus 4 sin log x, we need to show x square y2 plus xy1 plus y equal to 0. Okay, so this is again a 5-mark question on differentiation, successive differentiation. So we have solved this question there. Refer the video and practice it once again. 46. Next, 47th question, at least we have discussed it. I think on Monday we have discussed this integration of 1 upon x square minus a square. Okay, integration of 1 upon what? X square minus a square dx is equal to, okay, so this is equal to what? 1 upon 2a. Okay, 1 upon 2a log of x minus a upon what? X plus a plus c. Okay, so we need to prove this. So the proof we have discussed. Okay, and then also they have see. So the proof will be for 3 marks. Proof will be for 3 marks, and 2 mark will be for example. And if the proof is lengthy, if using by parts, if you need to simplify, then it will be 4 plus 1. Okay, 4 plus 1. Next, question number 48. So see, find the area of the region bounded by the ellipse x square by 16 plus y square by 9 equal to 1 using integration. Okay, using integration. Okay, so just we will discuss the method here. See, the given ellipse is of the type x square by what? 16 plus y square by 9 is equal to what? 1. So we need to convert it in terms of what? Y first, and then draw the figure. Okay, so once we draw the figure, we will get it in the form of, okay. So here the vertex, A vertex will be square root of this. It will be 4 comma 0, and then the vertex B will be 0 comma 3. So we are considering this as the shaded region. So the required area, and the required area will be what, 4 times the shaded area, or this will be 4 times 0 to what, 4 y dx. Okay, so by solving the equation 1, we will get the value of y, substitute and simplify. So here again we are making use of the formula a square minus what, x square dx, which is equal to x by 2 root of a square minus x square plus a square upon 2 sine inverse x upon a. Okay, plus c. So we have to substitute the limits and simplify it. Okay, so all the questions, 6 questions we have covered. See, ninth question, 50th question at least is the proof. Okay, so all the proofs we have discussed from 3D. The question has occurred from 3D, proofs of 3D. Okay, then 49th question is also a fixed question. Every year it is occurring, a linear differential equation, a solution of what, linear differential equation. So pay attention here. The question is of the type x dy by dx plus 2. See, pay attention here. The question is of the type see, x dy by dx plus what, 2y is equal to x square log x. So we need to divide this by what, x first. So we get it in the form of dy by dx plus what, 2 upon x into y is equal to x log x. Okay, so this we need to compare it with the standard form, that is dy by dx plus what, py is equal to q. Okay, so this is the standard form. So we will get the value of p. So here p will be equal to what, p will be equal to 2 by x, and q will be equal to what, x log x. Okay, x log x. Okay, so by making use of the integrating factor, okay, and the solution, we can find out the solution. We will discuss this. Pay attention. So we know what is p value. Pay attention here. So we need to calculate the integrating factor. Hope you have solved this example. This example have you solved in your so the question is fixed, question is fixed every year on linear equation. Okay, so there is a formula for this. So first we have to calculate what the first step is. After calculating p and q, we have to calculate the integrating factor. So integrating factor is what, e raised to integration of p and dx. So this will be e raised to 2 by x dx. Okay, so 2 is constant, 1 by x derivative will be log x. So it will be 2 log x. Okay, or this will be e raised to log x square, or e raised to log f of x, it is directly equal to what, x square. Okay, so the solution is, okay, solution is of the form of what, y into integrating factor. Okay, integration of q into integrating factor and dx plus what, c. Okay, so we need to substitute y into c. Integrating factor is what, x square. Q value is x log x, so it will be x log x into x square and dx plus c. So we need to simplify the RHS. It will be of the type x cube log x dx plus c. Okay, so we have solved. So see, it will be x square y is equal to, here you have to apply integration by parts. Okay, first function and a second function. So islet, so log function will be the first function, this will be the second function. So on simplifying it, we will get it in the form of, okay, I will write the simplified part directly. It will be in the form of x raised to 4 upon 4 log x, okay, minus 1 by 16 x raised to 4 plus c. Okay, so this is the answer we are getting. Last step you can shift x square or keep it as it is. Okay, so this will be the final answer. Okay, so try it. One question is occurring every year on linear differential equation, LDE. Okay, LDE. Two forms are there. This is the first form, dy by dx, and another form is dx by dy. Okay, dx by dy plus what px is equal to q. Okay, so two forms are there. So either the question will be on this form or on this form. Okay, next we will be discussing the part. So say part E, the last part of this paper. Part E, pay attention. Okay, so see question number 51. Okay, so in question number 51 you have two options. Okay, either you can solve the question on integration or the question on LPP. Okay, so LPP maximum questions we have covered. This 51 I will be discussing. See in okay, so here either one of these two you have to solve, either A or B. Like similarly in 52 the question is on determinants. Okay, and you have to find A inverse. Okay, and another question is on continuity. Okay, this question is on what? On continuity. Okay, continuity question, or a question on what? Determinants. So both the questions of 52 we have already solved. Okay, so go through the video. If any doubts are there, you can ask. Mhm. Then now we will discuss the last question, that is 51 question. Okay, question number 51 on integration. Okay, pay attention. Question number 51. So we will discuss the proof and then solve this example. Okay. So this was the last part. Yesterday we had to discuss, but because of the insufficiency of the time, time was not sufficient, so we couldn't cover there. So we will do it now. Okay, another 10 minutes are there. We will cover this 51 question. 51B at least we have done it properly. 52 is also covered. Okay, both all these questions are covered. You all practice it once again. Okay, so 51 we will do now. We try to solve the 51. So see, seven properties are there. Yesterday we discussed that. So out of seven properties, property number five, sorry, 4, 5, 6, 7. Okay, are important. The last four properties are important, and the examples are based on that. Okay, so see, pay attention. So here the property is the integration from minus a to a f of x dx is equal to 2 times 0 to a f of x dx. Okay, or it is equal to 0. Okay, so it is 2 times 0 to a f of x dx is f of x is an even function, or it is equal to 0 if f of x is an what? Odd function. Okay, if it is an odd function. So if it is an odd function, it is equal to 0. If it is a even function, and then it is equal to 2 times 0 to a f of x dx. Okay, so we will discuss the proof for this. Okay, solution. Okay, So see, in the solution, we are considering the property. We need to prove it. So first, what we will do is we will consider the LHS of the property A to A f of x what dx. Okay, so this can be written as, see, A to A. 1 minute, see, pay attention. See, this is a negative number, suppose, and this is a positive number, and in between we are considering it as 0. So what we are doing is we are splitting it as A to 0 f of x dx plus what 0 to A f of x dx, and we are considering this as what equation 1. Okay, so minus a to a, we are splitting it as minus a to 0 f of x dx plus 0 to a f of x and dx. Okay, so next, okay, what we are doing is we are trying to replace this minus a to 0. Okay, so we will consider minus a to 0 f of x and dx. Okay, so here what we will do is we will substitute x is equal to minus t. So when x is equal to minus t, we get dx is equal to what? Minus dt. Okay, and then see, when change of limits, we need to change the limits. See, when x is equal to minus a, t will be equal to plus a, and when x is equal to 0, t will also be equal to 0. Okay, so this integral will get reduced to, so it will get reduced to z minus a, it is a, to what 0 f of minus t, f of minus t, and minus what dt. Okay, because dx we have got it as minus dt. Okay, now see, this minus sign, we can make use of the second property. So when we interchange the limit, the negative sign will turn into positive, or the sign will change. Okay, so this will be 0 to a f of minus t. Okay, f of minus t and dt. Okay, so whatever this negative sign is there, it gets cancelled after the change of limits. Okay, next, we will get it in the form of, say, 0 to a f of minus t and dt. Okay, so this, by using change of variable, that is the first property, we can write it as minus x dx. Okay, and this I'll consider it as 2. Okay, this I'll consider it as 2. Okay, now see, we are replacing this 2 in 1. Okay, so substituting, see, equation 1, equation 2 in 1, so we get it in the form of, see, minus a to a f of x dx will be equal to, see, 0 to a f of minus x dx plus again 0 to a f of x dx. Okay, so this term what we had considered, we are replacing it by 0 to a f of minus x dx, or on simplifying, see, integral is same, so 0 to a, we get it as f of minus x plus what f of x dx, and this will be our equation number 3. Okay, so now we have two cases here, case 1 and case 2. So see, case 1, okay, when f of, okay, so case 1, so see, when f of x, okay, f of x is what, even. Okay, when it is even function, so when it is even function, we know f of minus x is equal to what, f of x, and therefore, see, from 3, this integral minus a to a f of x dx will be equal to, see, in place of f of minus x, we are replacing it by f of x. Okay, so this will be 0 to a f of x plus what, f of x, and f of x plus f of x, it is nothing but what, 2 times f of x, so it will be 2 times 0 to a f of x dx. Okay, so this is the case 1. So case 1, when the function is even, we are replacing f of x by f of minus x by f of x, so we are getting it as 2 times 0 to a f of x and dx. And similarly, in the case 2, okay, now we will be discussing the case 2. So in case 2, here we are considering odd function. Okay, we are considering the odd function. So see, in the case 2 when we consider the odd function. So in case 2 when we consider the odd function, case 2. So when f of x is what? Odd. Okay, so when f of x is odd, this f of minus x will be minus f of x. So again from equation 3, okay, equation 3, this will get reduced into, say, it will be 0 to a. So see, f of minus x is minus f of x. So in place of f of minus x, we will be writing minus f of x and then again plus f of x dx. Okay, so plus f of x minus f of x will cancel, it will be equal to 0. So in case 2, when it is odd function, it will be equal to 0, and when it is a even function, it will be equal to 2 times 0 to a f of x dx. Okay, 2 times 0 to a f of x dx. Okay, so this is the property which we have proved. Okay, so 51st question. So see here, if minus a to a f of x dx, so when it is a even function, it will be 2 times 0 to a f of x dx, or it will be equal to 0 when f of x is a odd function. And then we need to evaluate now. So hence evaluate minus pi by 2 to pi by 2 sine 7x. Okay, sine raised to what? 7x dx. Okay, now see, it's very simple. See, sine raised to 7x. Okay, sine raised to 7x. See, this is actually, see, if I replace this sine raised to 7x by minus x, okay, this will be minus sine what? X raised to 7, or this will be equal to what? Minus sine 7x. Okay, so sine raised to 7x is what? Odd function. It is which function? Odd function. So therefore, directly the answer of this will be equal to 0. So you need to show it is odd function, and by using the above property, since this is a odd function, directly the integral of this will be equal to 0. Okay, so you will be getting 4 marks for the property and 2 marks for the example. Okay, so this is the 6-mark question on integration. Okay, so get prepared with the properties, 4 properties, so you can easily attempt this question, or you need to be very perfect with LPP question. Okay, so this completes the paper discussion. Okay, now see, from the blueprint point of view. Okay, from the blueprint point of view. Okay, what can be your strategy? I will be discussing. Okay, so see, pay attention. So what we can do here, see, so especially if you score well in 2-mark and 3-mark section, you can easily score above 75 in the maths paper. Okay, in the maths paper. Okay, so see, in the morning class I discussed, for part A what you will do, you make use of model papers. Okay, you make use of model papers. Okay, practice at least 5 model papers are been given there, so you will get 5 into, okay, so 45 questions you will get there. Okay, and then practice all the summary points. Okay, practice all the summary points. Okay, practice the summary points and the definitions. Okay, so definitions, vector definition, LPP, definition of LPP, definition of vectors, and definition of matrices. Okay, so if you do this, so out of at least 20 marks in part A, you can score at least 15 to 18 marks. Okay, 15 to 18 marks. And see, you can refer the papers from 2015. Okay, 2015 to 23, all papers you can refer. Use all the 1-mark questions. Okay, so 1 mark, see what, 1 mark of 1 mark part A, all the questions you all practice. So even if you do this, so from 2015 to 23, you have 8 question papers with you. So 8 into 10 questions, so again you have 80. So this 80 plus this 45 I think will be sufficient to help you score 15, at least 15 to 18 marks in part A. Or if you do it properly, you can get 20 out of 20 also here. Okay. Next, in part B and part C, try to prepare part B and part C. Try to prepare 6 plus 2. Okay, 6 questions you need to solve, but try to prepare 2 questions extra. Okay, so 2 questions extra. And in part D also 4 questions you need to attempt, but again try to prepare 2 questions extra. Okay, so for C, part B and part C. Okay, for part B and part C, the chapter on vectors is very important. So for part C, the chapter on vectors is very important because we are getting 2 3 mark questions here in vectors. Okay, so practice the chapters on vectors properly and differentiation. For differentiation, you have 2 questions, and vectors you have 2 questions. So 4 questions will be covered, and then 1 question you have from relation and function, matrices, inverse trigonometry, and matrices. So easily you can attempt all the 6 questions here. Okay. So you concentrate for part C. You need to concentrate on vectors and differentiation properly, and then for part B, in case of part B, uh, okay, there is no specific topic, but probability 2 questions have been asked. Okay, so for part B, you need to be perfect with the questions on probability. So because 2 questions have been asked in probability. Okay, and E part at least is very easy. Okay, you practice 5 model papers, all the questions properly. So from there only you will get the question. Okay, practice all the 5 model paper questions. Okay, so this is how the strategy you can develop. Okay, and then see, from this is from paper point of view, and from lesson point of view. Okay, see, relation and function, it, inverse trigonometry, vectors, 3D. Okay, and LPP. So these chapters you need to do very thoroughly. So if you do these chapters, okay, plus all are perfect with matrices and what, and determinants. Okay, so here you will be scoring 30 in these chapters. 35 marks you will be scoring here, and here you will be scoring 20 marks. Okay, here you will be scoring 20 marks. Okay, so 35 plus 20, it will be 55, plus perfect the differentiation and application of differentiation. Okay, so do these chapters. So here if you do it perfectly, you will be fetching around about 27 marks. Okay, here. Okay, so 35 plus 20, plus again 20, so 77 marks preparation. And then you can keep integration chapter. Integration chapter, only you can discuss the main special types and all, plus application of integration. Okay, so this will help you to attempt extra questions. It will help you to attempt extra questions in part D as well as in part E. Okay, so integration and application of integration you do, it will help you in part D and part E very easily. Okay, so this is the strategy paper, question paper wise and chapter wise. Better try to cover this. So here you can spend 2 days time, you cover this. Okay, here you can spend 1 day, and here you can spend another 2 days, and you can spend 1 day here. So altogether, within 6 days, you can revise the full syllabus. Okay, full syllabus. Okay, so once again, and try to solve another one model paper by itself. So you can refer the videos, you can go through the videos. It will help you to cover all the 5 mark and 3 mark questions. Okay, and if any other doubts are there, you can send it in the group. Okay, so all the very best. Prepare properly. And better see, when you are entering the exam hall. Okay, and when you are attempting the paper, better cover the part E and part D in 1 hour. Okay, so if you cover this in 1 hour, then there will be no problem, because most of the students say the paper will be lengthy. Okay, so better if you cover part E and part D first in the first 1 hour, then you can easily cover the entire paper. Okay, so all the very best. Okay. Hope you get success in the maths paper. Hmm? Take care then. So we will stop here. Hmm? If any doubts are there, then we can have a session, or else we will stop. Okay. All the best. Bye.